Hey team, in this video we are going to go through the Headstart exam questions and go through the answers to them so that way you can check your own work and check any questions that you might have gotten wrong. Alright, so let's start here. Question 1 and 2 both relate to this situation that's on the screen. So we've got the back-to-back ordered stem plot, shows the distribution of maximum temperatures in Celsius of two towns, Beachside and Flattown, over 21 days in January. And question 1 lets us know that we've got two variables here. So this variable temperature or this variable of town, Beachside or Flattown. And we have to decide if they are categorical, numerical, or if they're both the same. This question here, so temperature, because that's something that we can measure, like how much, how many. So this is definitely a numerical variable for us. Okay, and if we're talking about the town here, then Beachside or Flattown, that's a categorical variable. And to be more precise, then this would actually be nominal because they're not ordered, they're just two different towns. So the answer to question 1 then is going to be D. I know C says categorical and numerical, but the key difference here is this word respectively. So it means saying them in order. So in order, our variables were given to us as temperature and town. So we say numerical and categorical, and the answer is therefore D. If we scroll down to question 2, question 2 wants the range of maximum temperatures in Beachside. Now, quite a few people, I think, actually used the temperatures for Flattown, but because it wants Beachside, it means we need to be using this data that's on the left-hand side. So remember that if we want the range, we need to take the, maximum temp minus that minimum temp. And if we scroll up here, the maximum for Beachside is 38. And the minimum for Beachside, so we're reading off the left-hand side, is 1 and 5. So that there is 15. And 38 minus 15 gives us 23 degrees Celsius. So the answer is B. The next lot of information here is this dot plot, which relates to question 3 and question 4. So it says here that the dot plot shows the distribution of the number of bedrooms in 21 apartments advertised for sale in a new high-rise apartment block. First question, question 3, wants the mode of the distribution. Remember, the mode is the most frequent or the most occurring. And so we can see here that there's 1, 2, 3, 4, 5, 6, 7, 8 dots for one bedroom apartment, and that has the highest number. 3 over here has 1, 2, 3, 4, 5, 6, 7. So the answer is A. Question 4 wants the median of the distribution, and remember this is then the middle number of the data set. Okay, there are 21 apartments, so we need the 11th one. So again, there was 8 dots in the first column, so 1, 2, 3, 4, 5, 6, 7, 8. If we count 9, 10. This dot here is the median. I always like to double check after that I've got 10 more. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the median then is actually 2. And so that will be our answer for question 4. All right. Question 5 and 6 then relate to this graph, and it is split over 2 pages. This graph shows the distribution of test marks obtained by a group of students is displayed in the percentage frequency histogram, which is shown here. Now, on the bottom of the axis, we've got the test marks. So the maximum marks that they could get is 60, and the lowest marks they could get is 0. So this first column here is showing then what percentage of students got a mark between 0 and 5%, in which case this is 2. If we come back down to question 5, it wants us to know the pass mark on the test was 30 marks and the percentage of students who passed the test is. So if the pass mark is 30, which is here, the percentage that passed the test is how many percent got more than 30. Now, to approach this question as well, Part 6 wants us to find the median, so I would actually spend a moment right now to look at each column and write down what percent they all represent. So this here is 3%, 2%, 3, 6, 6, 7. I've already done this by getting a ruler each time and using my ruler just to interpret across with those numbers. So I do recommend you do that to make sure you're accurate in getting these percentages as well. So 14, 16, 18, and 12 are the last ones. I then actually put all of these in my calculator and added them all to make sure it added up to 100. And I know that might sound a little bit trivial, but I did this as a check mechanism to make sure I actually hadn't made a mistake. Because if it ends up being 99 or if it ends up being 101 or something, then I haven't written all of the percentages correctly. But this does add up to 100%, so I know I'm good there. If I want now the percent of which is higher than 30, what I need to do is add the percentages for these columns from 30 across. So I need to go 7 plus 11 plus 14 plus 16 plus 18 plus 12. And you can see on my calculator there that is 78. So when I scroll down here, my answer for question 5 is D. Now question 6 wants the median mark. Remember, the median is the middle of the data, and it wants to know where that middle sits, okay? So what we actually want to do is, this is all by percentage, but I want to see, well, where does 50% sit? Because that 50% is like the middle of the data. So I want to go through and add these columns until I get to 50. So if I do 2 plus 3 plus 2 plus 3 plus 6 plus 6, that gets me to 22%. If I add on the 7 and add on the 11, I get to 40%. And if I then add on that 14, I get to 54%. So this tells me that my median then is sitting somewhere in here in this range of 40 to 45. So in answer then to question 6, my answer is going to be B here, that it's between 40 to 45. Question 7 now looks at this segment and bar chart. An animal study was conducted to investigate the relationship between exposure to danger during sleep and chance of attack, and the results are summarized below. A few people were able to interpret this correctly, but didn't then interpret the colors correctly. So first of all, the question says the percentage of animals whose exposure to danger during sleep is high, which means we need to be looking at this column here, and whose chance of attack is below average. So it means I then need to look at the percentage of this darker number. Now, if I do look at that darker number, we can see here that it's in this 80 to 90% part. So my answer is going to be E here, 86%. We've got 3 more questions left, and this question here, the dot plots, the box plot is for question 8, 9, and 10. So it says the box plot below shows the distribution of the time in seconds that 79 customers spent moving along a particular aisle in a large supermarket. So they're all in one aisle, and it's measured how many seconds they've spent there. The longest time in seconds spent moving along this aisle is closest to. Now, the longest time is the highest value, and even though we know these dots represent outliers, there's still values that existed in the scenario. So we want to look at this one here because that's the highest value, the longest time, and we would say then it is closest to 450. So for 8, the answer will be D. Then it says the number of customers who spent more than 90 minutes moving along this aisle is closest, 90 seconds, sorry, is closest to. Now, if we look here, this is 90, and I think we can agree that 90 looks like it's approximately the Q3 value. Remember then that each part of the box and whisker plot represents 25% of the data. So we're saying 25% is greater than 90 seconds. However, the question wants then the number of customers. So we need to take this percentage, so 25 then over 100, and multiply it by 79 because there were 79 customers in the aisle that were measured. And if I then pop that in my calculator, it comes out to be 19.75. So I'll say it's closest to 20 customers that then spent more than 90 seconds moving along the aisle. Question 10 then, the final one, it says from the box plot, it can be concluded that the median time spent moving along the supermarket aisle is, and there's a few things for us to work out. What I will say is, when it's saying that word concluded, it's saying that we know for sure this statement is 100% true. So we can estimate here what the interquartile range is, and I think we could argue that the interquartile range is 90 minus 20. So it is approximately 70. And we could see that the median is somewhere between 30 and 40, so maybe it's approximately 35. So yes, if we look at D, the median is half of the interquartile range-ish. But the thing is, we can't conclude that because we've just made estimations here, so D is going to be wrong. Also, if we look at the range, then the range is like 450 to 0, so it's 450, and then that median of 35 is a lot less than a quarter of the range, so that's gone as well. So we've got to come back to these ones that involve the mean time. Now, if we look at the shape of the box plot, hopefully you agree with me that this is positively skewed, because we've got more numbers down that lower end of the data set, and all these outliers over here would be influencing the mean. So potentially our mean might be like somewhere up here. It could be even higher, because we don't know what all of these other values are, but the mean is definitely getting skewed by these larger outliers that we have. So what we can say is if the mean is sitting somewhere to the right of our median, we know then that the median is less than the mean time, and so our answer for question 10 is going to be A. I'm going to stop this here for us, and I'm going to record a second video going through the short answer part. Thank you.